Hi everyone, I hope you're well. This is the introduction for Lab 11 lists. Okay, so we're going to talk about percentile-based statistics, lists in Python, which we've seen. Some of our earlier examples with die throws, for example, you were working with lists. And then int conversion, that we'll need for the percentile-based statistics. And then the lab introduction will be separate. Okay, this definition of percentile is a bit of a mouthful. So it's a value below which the given percentage, so the input here is a percentage of items in a collection fall. Right, so percentile converts from a percentage to a value. So it's the opposite, or we would say in mathematics, the inverse of percentile rank, which went from a value to a percentage. So let's discuss an example. I'm going to change this up a little bit to something that you may be able to visualize a bit better. Imagine we wanted to find the 75th percentile height of everyone in class. So what we would do is arrange an everyone in a line from shortest to tallest. Now in computer science we call that sorting. We're sorting people from height, and we end up with a line. And in this case, the line corresponds to Python's list. Everyone's in a line from shortest to tallest. Then we would count the number of people in line, take 75% of that. Right, so let's say we had 20 people. 75% of that is 15. So starting at the beginning of the line with the shortest person, we would count to the 15th person, measure their height, and that height would be the 75th percentile. Right, so that's how we would do it with people. In the lab, you'll be doing this in Python. Okay. Quartile, the first quartile, is the 25th percentile. The median is the 50th percentile, so the halfway point. And the median represents that halfway point. So the median value splits the data into two equal pieces. One piece, all the values less than or equal to the median value, and the second piece, all the values greater than the median value. Okay, so let's compare mean, which we've been working with a lot, and median. Okay, so compute the mean and median of this first set of numbers, A. You can pause the video here and do that yourself. Okay, so the mean, I got 50. I hope you got 52, or 50 also, not 52. To compute the median, we'd sort these from smallest to largest. So 48, 49, 50, 51, 52. And the middle value is 50. Right, so in this case, both the mean and the median are the same. Okay, do this again. Compute the mean and the median for the numbers in B here. Again, pause the video so that you can do it yourself. Okay, this time, the what I got for the mean was 185.71. For the median, the order is 48, 49, 50, 50 again, 51, 52, then 1000. So 50 is still the halfway point, so the median is still 50. This demonstrates that the mean is sensitive to outliers. We could consider 1000 here to be an outlier, whereas the median isn't so sensitive to outliers. Some people would say that using medians to represent a set of data is a better metric than the mean because the median isn't sensitive to outliers. Okay, let's look at some basic operations on lists in Python. So you'll be using these in the code you'll be writing in the lab. Okay, this first Python statement is how we create an empty list. Right, so this is roughly analogous to how we created an empty dictionary when we were working with dictionaries. Append is the function you use to add something to the end of a list. Okay, so we're starting from an empty list, then we append 19. So at this point, the only thing in the list is 19. Then in this third statement, we're appending 5. So remember, that goes at the end of the list. So the list is now 19 followed by 5. And then in this fourth statement, we append 42. So now the list is 19 followed by 5 followed by 42. Now, this notation is how we get something out of the list. This is called, the number in the brackets here is called the index, or think of it as the position. Now, for reasons I won't go into, the first position, where 19 is, remember 19 is at the beginning of the list, its position is 0. So my list, indexed by 0, will be 19, because 19 is the first item in the list. So my list indexed by 2 will be 42, because, well, let's just count these off. 19 is at position 0, 5 is at position 1, 42 is at position 2. So my list indexed by 2 is the value 42, the item at position 2 in the list. The Len function is used to get the number of items in the list. Right, so in this example, length will have 3 stored into it because the length of my list is 3. And finally, if you write a list, the name of a list, in this case my list, dot sort, that will sort the items in this case, my list. Okay, so you're going to be writing a percentile function that will compute a percentile. So keep in mind, from the example that we talked about earlier, finding the 50th percentile or the 75th percentile height of everyone in class, we needed to sort the class by height, find out how many people were in class, right? Take 75% of that, and then find that person at that 75th percentage position. Okay, so in your function, you'll be making use of all of these. You'll be appending, you'll be creating an empty list, indexing the list, sorting it, and determining length. Okay. the index of a list has to be a whole number. When we do percentage, like the 75th percentile, we're dividing 75 by 100, which that can give us a decimal number, a number with a decimal portion. So this int function is used to convert a decimal number to a whole number. What it does is simply eliminate the decimal portion. Okay, so let's look at this simple example. 19 divided by 3 is 6 dot repeating 3. So if we apply the int function to it, value will have the whole number 6 stored into it. Right, and this is a shorthand way of doing whole number division. Let's just stick with regular division and the int function. Okay, a couple of Socratic questions. Okay, so as I've been doing, I'll introduce the question and then pause. And why don't you pause the video and think about the answer. Okay, so question 1. Here's a collection of 10 items. What is the 50th percentile? I'll pause. Okay, the first thing we have to do is sort the list and then go halfway into it. We know we have 10, we know the length of the list is 10. We want the 50th percentile, so 50% of 10 is 5. But the first thing we have to do is sort the list. So I think I did that. Okay, here's a sorted list. All right, so what's the item at position 5? And I'm going to, in this example, I'll count starting from 1 because I'm not Python. 1, 2, 3, 4, 5. 18 is the 50th percentile value. Okay. Question 2. What is this is the same collection, the same list of 10 items. What is the 90th percentile? Again, I'll pause. Okay. The 90th percentile is D, 44. Okay, let's go back to this. All right, so 1, 2, 3, 4, 5, 6, 7, 8, 9, 44. Okay, what is the value of this expression? What number gets stored into value here? So the answer is 4, right? 19 divided by 4 is what? 4 3/4. Throw away the decimal part. That gives us 4. Okay. This one's a little tough. I'll just pause and let you think about it. Okay, the answer here is D. Let's talk about what's going on. So remember, to get this 25th percentile, we're assuming that data here are already sorted. We want the position corresponding to the 25th percentile. Okay, let's work on this from the inside out, right? Because the parentheses here are important. Okay, so we need to know the length, or the number of items in the list. So we get that with len data. Then we want to subtract 1. We're subtracting 1 because of how the position of the first item is 0. Okay, so this accounts, subtracting the 1 accounts for that for us. Then notice we have parentheses here. That's for order of operations, right? Because we want the subtraction to occur before the multiplication. So here is the division to get us 25%, right? And then multiply that 25% times the length of the list minus the 1, and then that whole value, well, it's not a whole number, it's going to be a decimal number, but we want to convert it to a whole number, so we use the int function, and we're applying it to the entire expression. So this parenthesis for int matches this end parenthesis. You're going to be using this expression with a modification in your code. Okay, so note carefully where the parentheses go. Your percentile function will have the percentile as an input. Okay, so in your percentile function, you won't use 25. You're going to replace 25 with the name of the percentage input to the function. Okay, so keep that in mind. And at this point, you might want to write this down, or refer back to it when you write your function. Okay, that completes the introduction to the list lab. You all take care. Bye.